I want you to think of at a time you locked yourself out of your house. Or maybe your car.
Oh, yeah, we've all been there.
Right. You're just standing there, patting down your empty pockets, looking through the glass at your keys, sitting right there on the kitchen counter.
The worst feeling.
It really is. Think about that sheer, immediate frustration. And honestly, think about the blunt force you secretly wanted to use in that exact moment just to smash your way back in.
Just grab a rock and be done with it.
Exactly. But now, I want you to imagine doing that, but you are wearing over 50 pounds of heavy, restrictive thermal gear.
Yeah, that changes things.
Right, and the environment is hostile, your visibility is, well, it's nearly zero. And there is an examiner standing right next to you holding a stopwatch.
Ticking down.
Yeah, ticking down from exactly 4 minutes and 40 seconds.
It's intense. I mean, it completely shifts the entire scenario from just a minor daily inconvenience into this incredibly pressurized, high-stakes performance.
Yep.
Especially when you factor in a really crucial piece of fire-grown reality, which is that a free-burning fire doubles in size every 60 seconds.
Wow, every 60 seconds.
Yeah, so that 4-minute and 40-second window, it isn't just some arbitrary testing metric they made up. It is the literal difference between a rescue and a recovery.
So the pressure is just unimaginable. Well, welcome to the deep dive. Our mission today is to decode this high-pressure, highly methodical world of firefighter forcible entry.
It's a really fascinating subject.
It is. We are looking at an official performance objective outline. It's titled Forcible Entry PO Overview.pdf. And going through this source, it reveals that gaining access to a locked building is it's almost nothing like the chaotic brute force explosions you see in Hollywood action movies.
Not at all.
It's far more about surgical precision, applied physics, and incredibly strict psychological discipline.
Yeah, to really lay the foundation here, the source defines forcible entry quite simply. It basically refers to the techniques used to gain access into a compartment, structure, or facility when the normal means of entry is locked or blocked.
Makes sense.
But as we dig into this official testing objective, you will see that the physical break, the swinging axes, prying metal, shattering glass, that's actually only half the test.
Just half.
Just half. The mental sequencing, the ability to completely override your body's natural panic response, that's what truly determines success or failure.
Because before anyone even thinks about swinging an axe, there is this mandatory psychological reset that has to happen right there at the door.
Yeah.
Okay, let's unpack this. The absolute first mandatory step of this entire high-octane operation is something the document calls try before you pry.
Yes, the golden rule of forcible entry. The try before you pry method must be performed before any destructive action is taken whatsoever.
Which means
it literally means attempting to open the access point by normal means. The firefighter has to physically grasp the handle, test the door movement, and verify if the door is actually locked or if it's just temporarily obstructed by something on the other side.
Reading that made me laugh out loud, honestly.
Yeah.
It feels exactly like calling IT tech support and having them ask you, did you try turning it off and on again?
Right, yeah.
It seems almost insultingly obvious. I mean, you have a highly trained firefighter arriving at an emergency scene. Of course, they're going to try the door handle first. But the document states that skipping this step on the exam results in an automatic failure.
It does. And I know it seems obvious from the comfort of a normal, calm environment, but when the sympathetic nervous system kicks in...
The fight or flight response.
Exactly. When adrenaline and cortisol are flooding your system, sirens are blaring, people are screaming, the human brain experiences tunnel vision.
You just want to act.
Right. It tends to skip simple, logical solutions and jump straight into an aggressive action mode. So the try before you pry mandate acts as a physical anchor. It forces the brain to slow down and re-engage the prefrontal cortex.
Oh, that's really smart.
But checking the handle is just the beginning of what the source calls the initial size up. While they are interacting with that door, the firefighter also has to stand at a very specific angle, what the document calls off the line of force.
So instead of standing square in front of the door like you're about to knock on a neighbor's house, you're positioned off to the side. I assume this is purely defensive.
It is, yeah.
Because if there's a backdraft or if the hinges fail catastrophically, you don't want to be the projectile catching the brunt of that outward explosion.
Precisely. It is a highly calculated safety stance. And from that offset position, they perform a rapid visual scan of the door type, the frame material, and the specific locking mechanisms.
All while wearing that heavy gear.
Right. Simultaneously, they must be in full PPE, personal protective equipment. The protocols here are absolute. If the candidate determines they are in an IDLH environment,
Which stands for immediately dangerous to life or health, right?
Yes, exactly. If it's IDLH, they must have their SCBA, their self-contained breathing apparatus face mask, fully secured and in place.
Got it.
But if it is a non-IDLH scenario, a simple face shield pulled down over the eyes is acceptable.
Okay, so I'm looking at the grading sheet for this setup phase, and I have to admit, I find one specific requirement kind of baffling.
Which one?
Why does the firefighter have to loudly declare to the examiner, I am positioning myself off the line of force for safety, or physically shout that they are attempting normal means of entry?
The verbalization?
Yeah, I mean, if you are on the clock fighting against a 4-minute and 40-second countdown, wasting breath to narrate your own actions seems incredibly counterproductive.
It seems counterintuitive until you look at it from an evaluator's perspective. The examiner cannot see what is happening inside the candidate's mind.
Oh, I see.
Right. By grading the verbalization of safety protocols, the examiner is testing for conscious competence. They're proving the firefighter isn't just acting on blind muscle memory or sheer adrenaline.
Right, they need to know you're fully aware.
Exactly. Forcing the candidate to vocalize their analysis proves intent. It proves they are actively evaluating the environment and maintaining cognitive control.
So they're basically proving they are awake at the wheel, not just a passenger to their own adrenaline.
Perfect way to put it.
Okay, so the size up is done, the mental checklist is complete, and the firefighter has confirmed the door is well and truly locked. Now they actually have to beat the metal. And looking at the arsenal available in this document, I honestly assumed you would just grab the biggest axe and start hacking away.
Oh, the arsenal is certainly extensive. The document categorizes the tools into 4 main groups: cutting tools, prying tools, pushing or pulling tools, and striking tools.
That's a lot of options.
It is. You are looking at an incredible amount of destructive, heavy-duty power.
Yeah, we're talking about mauls, flathead axes, bolt cutters, and something called a Halligan bar. Let's paint a picture for the listener, because a Halligan isn't exactly something you find in a typical garage.
Not unless you have a very intense garage.
Right. It's this heavy, drop-forged steel multi-tool. It's got a flared, wedge-like fork on one end, and an adze, which is kind of like a flat, curved blade, along with a sharp pick on the other end. It literally looks like it was designed specifically to pry a bank vault open.
It is arguably the most versatile tool in the fire service.
But here's the thing. With all that highly destructive power waiting to be used, the source explicitly states that whenever possible, firefighters should attempt what they call the through-the-lock method first.
Yes, they do.
But why prioritize finesse? Like you said earlier, if fire doubles every 60 seconds, isn't it mathematically faster to just kick the door off its hinges or smash the frame to splinters?
What's fascinating here is the underlying philosophy of the fire service. They actually prioritize efficiency and property preservation whenever the tactical situation allows.
Property preservation during a fire.
Yes, because through the lock, forcible entry utilizes highly specialized tools, namely a K tool or an A tool. The document highlights this technique because it is often surprisingly fast and it does minimal damage to the structure.
Okay, that makes sense.
Because not every locked door hides a raging inferno. If it's a medical emergency, a water leak, or maybe a fire contained in a completely different sector of the building, unnecessarily destroying a home or business owner's property is something incident commanders actively want to avoid.
So it is essentially a highly aggressive locksmithing maneuver.
Pretty much.
The mechanics of this are brilliant. The K tool looks exactly like it sounds. It's a heavy metal plate shaped roughly like a K with sharp blades on the inner V.
Yep.
So the firefighter slides those blades directly over the lock cylinder on the outside of the door so it bites into the metal rim. Then they use a striking tool, like a flathead axe, to pound the K tool down so it grips the cylinder tightly.
And from there, it becomes an exercise in pure leverage. The firefighter takes the adze end of their Halligan bar, slips into a slot on the K tool, and uses the face of the door as a fulcrum.
Wow.
They physically pry the entire brass lock cylinder right out of the door mechanism. They are using raw leverage to snap the internal retaining pins holding the lock together.
So once that cylinder pops out, there is just an empty hole where the keyhole used to be.
Exactly.
And then the firefighter just reaches into that hole with a smaller tool, finds the internal latch or cam, and simply turns it to open the door normally.
Yes. And throughout this entire surgical maneuver, the verbalization mandate continues.
Right. They have to keep talking.
They must state clearly, I am setting the tool using a striking tool to gain purchase. I am manipulating the lock mechanism for entry.
But, surgical finesse doesn't always work. What if it's a heavily reinforced commercial lock? Or maybe the K-tool just strips the metal and fails to gain purchase?
That is when the candidate must seamlessly pivot to conventional forcible entry. You abandon the finesse and you bring in the raw leverage.
Okay, think about these solid, heavy metal fire doors you might walk past in your office building every day. The ones that are so heavy you can barely pull them open just to get to the stairwell.
Very heavy doors.
Right. Imagine trying to force that backward against a locked steel frame. The physical exertion required here must be immense.
It is exhausting. The document details the mechanics of it. The firefighter takes the fork end of that heavy steel halogen bar and drives it directly into the tiny gap between the door and the frame, right at the latch line.
Okay.
If the gap is too tight, they have to use coordinated striking, usually communicating with a partner who's swinging an axe, to drive that steel fork deeper and deeper into the seam.
Got it. And once the tool is set, the firefighter uses the door frame as a fulcrum and applies massive prying force to physically defeat the locking mechanism.
Right.
The source notes they often have to work multiple points, prying at the top, the middle near the lock, and the bottom of the door to slowly break its structural integrity. It sounds like an exhausting fight against geometry and steel.
It is a fight, yet it remains controlled violence. They are applying maximum physical force, but with absolute specific intent. And again, they are continuously calling out their actions. I am placing the fork of the tool above the lock to attack the latch. They're constantly proving that the force is directed, not frantic.
Okay, so let's assume forcing the door fails entirely. Or maybe the scenario presents a barricaded door where a secondary entry point is urgently required.
Then you go for the windows.
Right, the focus naturally turns to the windows. Now, I always operated under the assumption that glass is just glass. If you hit it hard enough with something heavy, it breaks.
Oh, that is a very dangerous assumption on a fire ground. Glass behaves in entirely different, highly predictable ways depending on exactly how it is manufactured.
Wait, really?
Yes. If you do not respect the physics of the material you are striking, the safety risks are enormous. The document explicitly dictates different entry rules based on the specific type of glass present.
Here's where it gets really interesting. This blew my mind when I read it. First, you have plate glass. Think of your standard older residential windows or large storefronts.
Okay.
The protocol states that for plate glass, the firefighter must utilize the blunt end of their tool, and they absolutely must strike the top corner of the pane. Not the middle, not the bottom, the top corner.
Right. And to understand why, you have to understand plate glass. It is annealed glass, meaning it was cooled slowly during manufacturing. When it breaks, it splinters into massive, heavy, razor-sharp shards.
Like huge daggers.
Yes, so if a firefighter strikes the bottom or the center of a plate glass window, the sheer weight of the glass above the impact point will cause those massive jagged sheets to slide straight down like a guillotine.
Oh, that's terrifying.
It is. Striking the top corner ensures the majority of the glass falls safely downward and away from their arms.
Okay, and then the document switches gears for tempered glass, which is what you find in car windows or modern commercial glass doors. For tempered glass, the rules are the exact opposite.
Totally different approach.
Yeah, you must use the pick end of the tool, the sharp point, and you must strike the bottom corner of the glass.
Because tempered glass is rapidly cooled during manufacturing, trapping incredible amounts of tension inside the material. It doesn't break into huge shards. It shatters instantly into thousands of small, relatively dull cubes.
Right.
Because of that internal tension, it operates almost like a structural web. By using a sharp point to break the tension at the bottom corner, the integrity of the entire pane fails simultaneously. It simply crumbles into itself safely.
That is so specific. The source also issues a warning about hurricane-rated windows. It notes they are becoming increasingly common, particularly in coastal states, and firefighters must anticipate massive reinforced resistance.
Oh yeah, those are tough.
They're essentially layers of glass sandwiched around tough, flexible plastics.
Exactly. They are designed to withstand flying debris at hundreds of miles per hour. Standard tools often just bounce off or get completely stuck in the synthetic layers. It requires a completely different level of sustained attack to breach them.
Like a highly dangerous game of operation.
Yeah.
You really can't just swing wildly.
No, you cannot.
And the required physical positioning to break any window on this exam is just as strict as the tool placement. The examiner is watching the candidate's hands like a hawk.
Oh, absolutely.
When swinging that tool, The firefighter's hands must be positioned above the point of impact, and they must remain entirely outside the door or window frame.
Because gravity is unforgiving. If your hands enter that frame, or if they drop below the impact point, gravity will bring those shards directly down onto your wrists and forearms, regardless of how tough your thermal gear is.
Right.
Furthermore, before the tool even makes contact, the firefighter is required to yell, "Breaking glass!" at full volume to alert any surrounding personnel or potential victims of the incoming hazard.
So you swing, the glass shatters, but you are still not done. You now have a frame lined with jagged edges. The document outlines a sequential clearing of those remaining shards.
It's not random.
No, the examiner grades the candidate on the exact order they clear those edges.
Using a tool, not their hands, they must clear the frame. The mandated sequence is top edge first, then the side nearest to the firefighter, referred to as the windward side, then the side away from the firefighter, the leeward side, and finally the bottom edge.
You know, I found myself questioning this specific sequence. If I'm standing safely outside a shattered window, why does it matter if I clear the left side or the right side first? Why not just drag a tool around the whole frame in one fluid circle?
Well, it comes down to anticipating the physical realities of the environment. You clear the top edge first to eliminate any remaining overhead guillotine hazards, like we talked about. Then you clear the windward side, the side closest to you. Firefighters wore bulky gear with countless straps, clasps, and air hoses. If you clear the far side first, you have to reach your arms across a row of jagged glass closest to your body, risking a severe snag.
Oh, that makes total sense. I wouldn't have thought of that.
Right. Additionally, windward and leeward refer to airflow. Fire creates its own intense wind currents. You clear the windward side to understand how the air is moving into the structure before fully opening the far side, which could drastically alter the fire's behavior.
Wow. It's like playing a high-stakes game of structural Jenga. Pulling the wrong piece of glass at the wrong time or reaching across the wrong angle creates a lethal compounding failure.
Exactly.
So we've talked about trying a handle, the surgical precision of the K-tool, the brutal leverage of a Halligan, and the physics of glass. But none of these physical mechanics matter if the operator loses their mental grip.
If we connect this to the bigger picture, this brings us to the core of the evaluation. Looking at the critical scoring factors laid out for the examiner, we find the true crux of the performance objective.
The grading criteria.
Right. The candidate is graded on sequence discipline, meaning try before you pry, has absolutely no exceptions. They are graded on tool identification. They are graded on safety verbalization. But the overriding metric that ties it all together is command presence.
That phrase stood out immediately to me. What does command presence actually look and sound like in the context of an examiner holding a stopwatch?
Well, it is not simply about being loud. The source requires the candidate to project auditory and physical authority over the chaos. The cadence of their voice, the certainty of their movements, it all must sound and look as though they are operating on an actual fireground. They must demonstrate that they are fully aware of the hazards and entirely in control of their own physiological response.
So if they sound hesitant, if they stutter while identifying a tool, or if they look like they are guessing about which corner of the glass to strike, they fail that metric.
A hesitant rescuer is a dangerous rescuer. That command presence must be sustained through the very last second of the scenario. The final required action isn't breaching the door, it is controlling the resulting opening.
Making sure it's actually safe.
Yes. The candidate must visually and physically confirm that no hidden hazards remain, no hanging glass, no sharp metal edges protruding from a destroyed lock.
And only then, when the path is totally secure for both firefighter entry and victim egress, the candidate formally announces, "Forcible entry operation is complete."
The backbone of this entire exam is what the document calls the quick memory flow.
Okay, let's run through that flow from start to finish, just to fully appreciate the sheer cognitive load placed on these candidates.
Sure.
You approach the door. You offset your stance for safety. You size up the locking mechanism. You check your SCBA mask. You try the handle. You choose your tool. You communicate your intent. You apply surgical leverage to the lock, or you drive a steel wedge into the door seam. You pry it open. You break the glass using applied physics. You sequence the hazard removal. You clear the frame, and you announce completion.
It's a lot.
Every single step vocalized, every hazard respected, and you have an absolute maximum time frame of 4 minutes and 40 seconds.
It is a staggering amount of sensory data to process and heavy physical labor to execute in under 5 minutes. But returning to our earlier point, that time limit dictates survival.
Right.
4 minutes and 40 seconds is an eternity for a victim inhaling toxic smoke in a 500-degree room, but it feels like a mere blink of an eye for the person on the outside fighting against reinforced steel. The grading sheet is really designed to force muscle memory to take over the physical labor, allowing the prefrontal cortex to remain entirely focused on safety, sequencing, and the rapidly changing environment.
So what does this all mean? When we pull all of these details together, this deep dive shatters a lot of illusions about emergency response.
It really does.
Forcible entry isn't about blind adrenaline or swinging an axe in a panic. It is about applied geometry and material physics. It is about strict, unyielding psychological discipline.
Absolutely.
It is about utilizing surgical tools to minimize property damage whenever humanly possible and maintaining a commanding mental presence while a stopwatch relentlessly ticks down.
It requires a flawless synthesis of mind and muscle. Once you understand the underlying mechanics, it leaves you with a very different perspective on the doors, the locks, and the windows we interact with every single day without a second thought.
It absolutely does. The comforting illusion of the impenetrable locked front door is completely dismantled once you read how methodical and scientifically precise the process of defeating it really is.
I will leave you with a final thought to ponder tonight. The next time you walk inside, lock your front door, turn the heavy metal deadbolt, and feel that familiar, comforting sense of absolute security. Ask yourself a question. Knowing what you know now about the physics of leverage and the vulnerabilities of lock cylinders, how long would your normal means of entry actually hold up against someone possessing the right combination of specialized tools, structural knowledge, and exactly 4 minutes and 40 seconds of unyielding discipline?
That is a deeply terrifying yet incredibly fascinating thought to end on. Thank you for joining us on this deep dive. Keep questioning the everyday world around you.